Thank you, Professor Mukherjee. And as a follow-up to that question, how significant is the toxicity related to selenium and uranium contamination in the groundwater?
Okay, so uranium is radioactive, right? So we know to start with that uranium, if excessive uranium is there, it will cause radioactive related diseases. Now, selenium is kind of a question mark. Like selenium studies was done a lot actually in the US back in the 70s and 80s, and they are known to be a contaminant to certain level, but not to to a great level. So yes, selenium again, each of these, they're in some way or other they are nutrients to our body, right? So that's something that we have to keep in mind. Arsenic is used as a medicine in several alternate medicine routes. So each of these are actually also required for our body. Selenium is specifically something that you take as even a food supplement. Um, but then there are some rocks, some sources where you can release selenium into the groundwater, and in a very excessive condition, they do create health issues. But their impacts are limited, much limited to the arsenic or fluoride that we talked about.
Thank you, Professor Mukherjee. Moving on to the next question. It's a bit engineering related question.
Okay.
Can the depth of water wells be modified in some way to get relief from groundwater contamination?
Right. So, okay. So this is a very useful question, actually, and it relates to a large way to the water usage policies by the various countries. So again, if I take the example of South Asia, mostly Bangladesh and India. So in earlier times, in the previous to 1990s, groundwater was mostly drawn from the shallower depths, like mostly like less than 70, 80 meters. And then the arsenic problem started showing up. In Bangladesh, subsequently, people discovered, I would say the word discovered, that in certain areas, um, in a deeper depth, more than 150 meters, the groundwater is, arsenic free. Knowing that information, they tried to study or kind of elaborate that idea in a more carpet way, like use that one local information to making policies. Eventually, what happened both in Bangladesh and India, few thousands, if not hundred thousands, wells were constructed between 1990s and 2020, which are as deep from 150 to 300 meters. And the idea is that these wells are all drawing deep groundwater, allegedly arsenic safe. What we have found that yes, in some areas they are actually arsenic safe, but in some areas, again, they are not. And you can blame it again back to the geology, the local soil geology, which would make some of these deeper groundwater to be arsenic safe versus some not. So I would like to go back again, suggesting that you need to understand not just one criteria, but kind of integrate all the information that you have, both the geology, the chemistry, the human practices, and of course the human behavior to bring out a solution, including using the deep groundwater.
Thank you, Professor Mukherjee. So the next question is on the latest buzzwords, machine learning, AI. Nowadays, machine learning models are being employed to predict water contamination. So do we have enough data, or are we generating enough data to make accurate predictions? And are there ways to ensure accurate predictions without using large data sets?
Interesting question. And again, it's kind of a chicken and egg question. In some areas, there are data. For example, like, some of the maps that I showed you, they are very intense data sets, like few million data points. Whereas in other areas, they don't. So consequently, what happens when you, and again, these are predictive tools, right? You should not take it as face value. Like you should not take it as occurrence. These are predictions. Now, these AI tools needs to honor the chemistry, the physics and the chemistry and the geology. Most of the time, the problem that I face with AI tools, because I also do a little bit of that, and my students do, that if you blindly use them, they would give you an answer which you have no way to prove or disprove. And most of the times they are actually wrong. Whereas if you know the hard science, I mean the physics and the chemistry and the geology that exist in the domain of study, the study domain, sorry, you possibly can use these AI tools much more effectively in areas also where you don't have data. So my answer to your question is that as long these machine learning tools are based on data, like they are data-driven models, I would have a question. Whereas if they are physics or physics chemistry based data sourced or data-driven machine learning models, I would have much more comfort and preference on those.
Thank you, Professor Mukherjee. We just have one final question.
Sure.
Actually, we have a lot of questions coming in from
Okay.
the audience. Perhaps we'll reach out to you separately with the
Sure.
questions. In this session, I'll just take one final question. So, what kind of technologies are available to help the at-risk communities? Considering that many of these communities may not be economically or socially well off, so are the existing technologies scalable and cost-effective?
I'm sorry, I missed the first part of the question.
So, what are some of the technologies that are being developed or are available to help at-risk communities?
At-risk, you said?
At communities which might be at enhanced risk
Okay,
for
okay, yeah.
water pollution.
All right. So if you have time, I'll just tell like a 1 minute story. Like about a few years back, I was working in one of these communities, again, very backward community, very poor, extremely rural. And, I went there and I saw, people literally suffering, like they have gangrene. Some people died through cancer and uh, they had this very elaborate water treatment plant just sitting on their backyard. So I asked them, okay, so how come you're suffering from all these water-related issues where you have this, technology just sitting on your backyard? Because the government has installed it. And the people said, sir, those were working until 1 year of their, installation. And after that, nobody came and took care of it. It's a fact that if you have a technology, you have to also maintain it. Most of the times, it does not. And that actually makes using the technology. So there are thousands of technologies. Most of them, they don't work because they are not maintained, the human angle. So they asked me, okay, you are taking our water sample, you are taking our photo. What is our benefit? How do we survive? So I kind of gave them a home remedy. Now, it's not perfect. I fully appreciate that it's not perfect, but it works. I asked them that go and buy some iron nails, like get some iron nails, like fresh iron nails. Take a bucket of water, put your iron nails in that water and keep it overnight. That iron would rust, and as it rusts, it would also absorb almost 80% of the arsenic that is in the groundwater. I'm sorry, that water in the bucket, which came from the groundwater. The next day, or maybe 2 days after, you filter it out with a piece of cloth. So, like at least the colloids and the particulate pollutants would go off. Of course, it would not take care of everything, but it's better than drinking, just raw. And I can assure you that that would take care, almost 80% of the problem. It's a very simple thing, the basic chemistry that we all know. And anybody can have access to that kind of science. It's just the usage of it. So my point is that you can have, very ground level technologies. You don't need very elaborate technologies. And those technologies are available. Most of them are not being used for commercial reason, and the other ones are not being used properly because of management issues. So people are suffering not because the problem is there. The problem is there and we have to live with it. So do we have the technology? Yes, we do. The technology varies from very cheap to extremely costly, very, very down to the ground to extremely high end. Still, why are people suffering? People are suffering, it's more from the human angle because things are not being used properly, things are not managed properly, and the access to clean water is something still in the distant future.
Thank you so much, Professor Mukherjee, for your patience with answering all the questions that we had from the audience. I'll now hand over to my colleague, Dr. Krishna.
Uh, Thank you, Professor Mukherjee. That was actually the punchline that we needed to end this session, and it was very wonderfully put.
Thank
So
you.
with this, we come to the end of our session. I would really like to thank Professor Mukherjee for taking time out of his schedule for this talk, and I'd also like to thank all our attendees today for their engaging and enthusiastic participation. We hope you enjoyed this broadcast, and we invite you to view the edited recordings of the past events in ACS Science Talk Library. On behalf of all of us at ACS, I thank you again for joining us today. We hope to see you soon for more ACS events. Until then, stay safe and healthy.
Thank you so much. Thanks so much
Sure.
for inviting to this,
Sure.
very
Sure.
renowned platform.
Thank you, Professor Mukherjee.
Thank you, Professor.
Thank you.